Now we're going to discuss chemical equations. Chemical equations are ways that you can describe the changes that occur during chemical reactions. Chemical reactions are chemical changes. They are transformations from reactants, reactants are what we start with, to products. The arrow symbolizes the change. So the chemical species on the left side of the arrow, the reactants, are what you start with. Bonds break, new bonds form, and then you end up with products, which is the chemical species on the right side of the reaction. So, if we think about the law of conservation of mass, by the law of conservation of mass, we know that what we start with is what we end up with. So that means that the number of atoms of each element on either side of the equation have to be equal. So in the reactants and products, the number of atoms of each element have to be equal. And for this reason, we have to balance chemical equations. Balancing chemical equations is an art, and what I would like you to do is be very, very careful about how you write and balance your chemical equations to describe chemical reactions. First of all, every chemical species must be accompanied by specification of its state. And by state, I mean state of matter or phase of matter. And there are only 4 phases of matter that we need to worry about here. Solid, and in a chemical equation, you could denote a solid with a lowercase letter s in parentheses. Liquid, which you can denote with a lowercase letter l in parentheses. Gas, which you can denote with a lowercase letter g. And aqueous. Aqueous means dissolved in water. And you can denote aqueous with a lowercase aq in parentheses. And again, like the name implies, that means that whatever the species that you're talking about is dissolved in water. So the best way to approach learning how to balance chemical equations is to do examples. And what this involves is translating sentences into chemical reactions. So let's do an example where we have hydrogen gas and oxygen gas combining to produce liquid water. Can we write a balanced chemical equation for that process? All right, so one thing that is crucial to know is that quite a few of the non-metals on the periodic table occur naturally as diatomic species. And hydrogen and oxygen are 2 of them. So hydrogen and oxygen occur as these diatomic gases. So you should write their formulas as H2 and O2. They each get a little lowercase g because we were told that they're gases. They combine to produce liquid water. That produce is code for an arrow. So we know we have water, H2O, and it's a liquid. So I'm giving it an L. Now we have to balance the chemical equation. We have to make sure that this equation has the same number of hydrogens and oxygens on either side of the arrow. So one way we can kind of keep track is to, underneath the arrow, list all of the elements that are involved in the reaction. So I have on the left, the reactants, I have 2 hydrogens and 2 oxygens. And on the right, in the products, I have 2 hydrogens and 1 oxygen. And I just get that by looking at the subscripts. So I need to somehow I wrote the wrong number here. I have 1 oxygen. I need to somehow turn that 1 into a 2 for the oxygen. And the only way I'm going to be able to do that is by putting a big coefficient 2 in front of that water so that I have 2 moles of water now represented on the product side of this reaction. Now recalculate. Every time you place a coefficient, so what I just did here was I placed what's called a stoichiometric coefficient. So every time you place a stoichiometric coefficient, you should recalculate. Now I have 4 hydrogens and 2 oxygens because 2 times 2 is 4 and 2 times 1 is 2. So in order to equalize the number of hydrogens, I can put a big 2, a stoichiometric coefficient, over on the left side, and that will bring me into balance. 2 times 2 is 4, and I still have 2 oxygens. So now my reaction is fully balanced. 2H2 plus 1 O2 gives me 2 H2Os. This is an equation that represents the combustion of hydrogen gas, and it is what the equation that's used in hydrogen fuel cell vehicles. So it's a very ideal, very clean combustion process. You can get a lot of energy out of this process, and the only product of it is water rather than carbon dioxide. So this is very promising as an alternative fuel. Hydrogen is promising as an alternative fuel.